5, we're adding on a bunch more definitions, postulates, theorems, adding on to our existing word bank of what we should have in our brains. A lot of these are more common sense things that we already probably know based on what we've learned so far, but we're giving them like proper definition, postulate, theorem names. The first one here is my vertical angle theorem. The vertical angle theorem is a super common theorem that we're going to see all the time. It says that vertical angles are congruent. If we remember what a vertical angle looks like in a diagram, it makes an X shape, and then the angles that are across from each other in that X shape are congruent. So we have two kind of pairs of them. The next two definitions are pretty similar. Number 1 is the definition of complementary angles. The definition of complementary angles says that two angles are complementary if and only if they sum to 90 degrees. So I see this both ways, right? It's a biconditional. I can see it work forwards and backwards. So sometimes we might see the word complementary, and we use the definition of complementary angles to then say angle 1 plus angle 2 equals 90 degrees. Or I might see it the other way around. I might have a statement that looks like angle 1 plus angle 2 equals 90, and then the next statement is saying those two angles are complementary by the definition of complementary angles. So it works both ways because of that biconditional. Same thing in the next one, definition of supplementary angles. We know that that just means that those two angles are supplementary if and only if they sum to 180 degrees. So angle 1 plus angle 2 equals 180. That's our pretty surefire way to know we're using the definition of supplementary angles there. The next two are kind of weird, and I don't like them so much, but we got to know them. The congruent supplements theorem states that if I have two angles that are supplementary to the same angle, then those two angles must be congruent to each other. So I'm going to draw us out like a little picture here. Basically what this says is if I have something like angle 1 here, or let's call it angle A, is 120 degrees. Then I have angle B is 60 degrees. Those two things are supplements, right? They add together to make 180. Well, then let's say that I also have angle C, which is 120 degrees, which is also supplementary to angle B. So C is supplementary to B, and A is supplementary to B. Therefore, by the congruent supplements theorem, we are saying that angle A is congruent to angle C. That's what the congruent supplements theorem states. It's kind of like the transitive property, but for supplementary angles in a weird way. So some people like to think of it like that, but it's just a weird way to say if two angles are supplementary to the same angle, they must be congruent to each other. And we have the same thing for congruent complements as well. So same idea. If two angles add up to 90 and angle B and angle C also add up to 90, then A and C must be congruent to each other. That's what that says. Questions on those two? Kind of weird ones. These next three all kind of work together, but very specifically how we do this. So all right angles are congruent is a reason that often is forgotten because it's so basic that we just forget that this could be a reason. If I have measure of angle, or angle 1 is a right angle, and angle 2 is a right angle, then I can say angle 1 and angle 2 are congruent. That's literally like what you are going to see. Angle A is a right angle. Angle B is a right angle. Therefore, angle A is congruent to angle B. Like, that is what it will look like in a proof. The next one, definition of perpendicular lines, states that AB is perpendicular to CD if and only if AED is a right angle. So what we're going to see with this guy We know the symbol for perpendicular, right? It's this upside down T shape. Oftentimes I'll see a line perpendicular to another line, and the next statement will be, well, they form right angles. In fact, if I have two perpendicular lines, they're actually forming 4 different right angles at that intersection. So I could say any one of those angles is a right angle. Notice, what it does not say is it does not say that those angles equal 90 degrees. All it says is that those angles are right angles. If I want to get something to be equal to 90 degrees, I have to use this next definition here, the definition of a right angle, which states that if I have something as a right angle, then its measure is 90 degrees, or vice versa, if and only if. Okay, so these two right here, definition of perpendicular lines and definition of right angles, often are going hand in hand. We first start with a perpendicular line, we say that something is a right angle, and then using the definition of right angles, we can say that it's 90 degrees. So oftentimes used together. Any questions on any of these new definitions, postulates, theorems? Okay, let's do a quick example. This is another example about this like congruent complements theorem thing. So if I'm looking at this diagram, what I need to point out here is I see these little right angle tick marks in here. I'm going to use those to kind of help me prove something about this diagram. The first one that I'm seeing is angle 1 and angle 2 form this right angle in here. So I could say that angle 1 is a complement of angle 2. Hopefully we also see the other right angle tick mark in there. Angle 2 and angle 3 form a right angle. So I could say angle 3 is a complement of angle 2. By the reflexive property, we know that angle 2 is the same as angle 2, right? It equals itself. So we could say angle 2 is congruent to angle 2. Then, by my congruent complements theorem, if two things are complementary to the same angle, then they must be congruent to each other. By that congruent complements theorem. Does that theorem kind of make a little bit of sense, hopefully? It's a weird one. Okay, ready for proofs? Here we go. We're going to start out by proofs like I always do by looking at my givens. So my givens are angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary. That's given to me. In the next step, remember, anytime we see a vocab word, my mind automatically thinks I'm probably going to have to define that vocab word. And we can see that happening in step 2 here. I go from the word supplementary to, okay, what does that mean? It means angle 1 plus angle 2 equals 180. It means angle 2 plus angle 3 equals 180. That is the definition of supplementary angles. Supplementary. What do we think about number 3? How did we get to step 3? What do we think? Look at step B, or step 2. How do we get there? Go ahead, give it a try.
Substituting angle 2 plus angle 3 for 180?
Yeah, that's exactly what we did. We saw that angle 2 plus angle 3 equals 180, so I can replace 180 in that statement with measure of angle 2 plus the measure of angle 3. That is substitution property of equality. Perfect. What do we think for step 4? Don't think too hard, Caitlin. Not subtraction, because if we think about subtracting, I'd have to subtract the measure of angle 1 from both sides, and I'd have to subtract the measure of angle 3 from both sides, and I don't have that. Think more basic than subtraction. Yeah. Not simplify. It's equal to itself. Angle 2 equals angle 2. Casper. Not symmetric. Which one's this equal to itself, Anna? Reflexive says that it's equal to itself. Okay, then, now that we know that, how do I then know that angle 1 equals angle 3? What did I say here? Yeah. Not symmetric. Casper? Do I have a congruent symbol in this step? Right here. So I can't use a congruent complements theorem or supplements theorem because I don't have the congruent symbol in step 5. What did I do? I have to link step 3 and step 5. Caitlin. This time I did do subtraction. Don't ask me why we did that step in the middle. I'm not entirely sure, to be honest with you, but we did it. We subtracted that measure of angle 2 from both sides to get just the measure of angle 1 equals the measure of angle 3. And then number 6 is a weird step. I'm not expecting you to know this one, but if we have two angles are equal, we have an extra weird step to say that they're congruent because equal and congruent don't necessarily mean the same thing. So if you see something that says definition of congruent angles, that's all that means. All right, flip it over. Let's do one more together, and then I'll let you try one. First statement, what's my reason? Casper. Perfect. Second statement, I got to fill in these blanks here. The measure of angle 1 plus the measure of angle 2 equals what? Based on my diagram, based on my given, Casper. 90. Oops. And why do we know that? What tells me that they're 90 degrees, Ian? Perfect. Oops. And we can say that twice, because it's true for both steps. And I'm looking at this, I see that vocab word complementary. I see two angles adding up to get 90. I know that's my definition of complementary. All right, step 4. It's giving us a hint. It says use statement 2 and statement 3. How do I know statement 4? Yeah. Substitution. Perfect. They're both equal to 90 degrees, so I can substitute one in for the other. What about number 5? What goes in this blank now? Think about what my proof statement is and what my goal is. What's going to go in this blank, Anna? Perfect. And how did I get there? Casper? Perfect. Subtract the measure of angle 2 from both sides. That's the subtraction property of equality. And again, that weird little switching thing happens at the end. I'm switching from an equal sign to a congruent symbol. Definition of congruent angles. Questions on this one? Okay. Talk to the people around you. See if you can figure out letter C. And then keep going if you feel confident. Okay. Number 1, what's my reason? Perfect. Number 2, it's telling me that's the definition of congruent angles, which it is. Remember, we're switching from a congruent symbol to an equal sign from our given. What do we get for number 3? Casper. Perfect. I'm saying angle W plus angle V equals 180. That's the definition of supplementary angles. And we know we've got that vocab word in there that's telling me I need a definition. Number 4 is not the same, though. What's number 4, Casper? What are you substituting? Based on step 2, we know that those two angles are congruent, so I can replace angle V with angle W. So that is substitution. Perfect. I thought that one might trick us, but we got it. What do we get for number 5 then? Caitlin? Perfect. We're combining like terms. If you said multiplication, you have to think about whether you're multiplying on both sides or just one side. And this one we've only got multiplication happening on one side. So then the rest of it should be pretty straightforward. What's number 6? What do we do to both sides? Division. Then in number 7, Caitlin? Substituted that V back in. And then we finish it off with letter 8 or number 8. Am I tricking you on this one, Caitlin? Definition of right angles. Definition of right angles is one of those ones that works both ways. So if I know that they are 90, I can say, and they must be right angles. Okay, perfect. Questions on that one? I got a couple quick ones for you, and then we'll be done. Letter A. What's number 1? What's my reason? Anna? Perfect. Vertical angles theorem. This is a weird one where my given doesn't come first for whatever reason they decided to do it. My first statement is based on my diagram. I see those two angles are vertical. Vertical angles theorem. Then step 2 is, yeah? Yep. I don't know why they put my given second, but they did. Step 3. Why do I know step 3? Caitlin? Perfect. And then step 4. Casper? Perfect. Remember, symmetric property of congruence, that's our mirror property. So we're flipping the two pieces. That's symmetric. Okay, and then letter B, we need to go through together for sure because this is a super common pattern that we're going to end up seeing. So statement 1, that's my given, of course. Like it is 90% of the time. What does that symbol mean in number 1? Casper? Perfect. So we're saying that J and K are perpendicular. Then in number 2, it says angle 1 is a right angle. Why do we know that? Why do we know that's at a right angle? Caitlin? Perfect. So it's not a vocab word necessarily, it's more of a vocab symbol. But if I see that symbol, most likely I'm going to be using the definition of perpendicular lines. The definition of perpendicular lines tells me that angle 1 is a right angle. In the next step, I'm then saying that that right angle equals 90 degrees. How do I know that part? How do I go from, Anna? Perfect. So like I said, this is a super common pattern that we see. We start with perpendicular lines. We then can say that we form a right angle. And then from there, we can say that that right angle equals 90 degrees. Super common pattern. They always are working together like that. Number 4, angle 2 is a right angle. How do I know that? Casper? Exactly. My pattern is going to repeat itself. There's not just one right angle at this intersection. There's actually 4 right angles. We only care about the 2 of them. So definition of perpendicular lines. So then my pattern repeats. Step 5 is definition of right angles. So again, we went perpendicular lines to right angles to 90 degrees. Finally, in step 6, I'm saying that those two angles are equal to each other. So what's that? Caitlin. This one is just substitution. So we do have that sneaky property that sneaks up on us sometimes. That's all right angles are congruent, but we can't use it here because I don't have congruent angles. It's got to be just substitution. Questions on that? Okay, fantastic.